Alrighty, you should be on 719 with me right now, which is just an inquiry lab. It's something that appears before we actually do lesson 2 with theoretical and experimental probability. But this is a good way to just introduce it to start with. And I'm going to do not really an experiment with you, but something a little bit more hands-on. Unfortunately, with the way things are this year, most of chapter 9 with probability, I would typically do some experiments in class with you. But since that can't happen, I'm going to just show a few here and there on video and just kind of explain and do the best I can with you. So this hands-on activity that we're going to start with has to do with number cubes, or the dice that you see in front of you. And if you look at step number 1, it's going to ask us to complete the table to show all of the possible outcomes for rolling 2 number cubes. And then what we're going to do is shade all of the possible outcomes that are doubles. So if you take a look here in this first column, you're going to start to see that one possibility, if you were to roll these cubes, that could happen, is you could get 1 and 1, just like that, which is your first set of doubles that you would see. Okay, so that's listed there. That's one possible outcome. A second possible outcome is you could get a 1 on the first cube and then a 2 on the second cube, just like you see shown. You could get a 1 on the first cube and then a 3. You could get a 1 and a 4. Where is it? There it is. A 1 and a 4. You could get 1 and 5. And you could also get 1 and 6. So you have those possibilities with the first number cube being a 1 and then rotating through on that second number cube. Okay, second column. You could roll the cubes and get a 2 to start with on the first cube, and then you could get a 1 on the second cube. You could get a 2 and then a 2. So again, another set of doubles there. You could get a 2 and a 3. And then keep going, right? So now we have to fill out the rest. So you could get a 2 and a 4. So we're going to write that down. So we're going to finish this table out. 2 and 5. 2 and 6. Okay, so you should start to see what's going on, right? The next column, you're looking at now taking that first number cube, and it's possible that that could start with a 3 and then a 1. And if you're working ahead of me, that's fine, because you're understanding what's happening here with the possible outcomes on these number cubes. You could get a 3 and a 2. You could get another set of doubles here at 3 and 3. 3 and 4. 3 and 5. And then 3 and 6. Okay, just like that. Okay, again, keep going. So for the first number cube, you could get a 4 and a 1, 4 and 2, and so on. Okay, keep filling out this table. So then when that column is done with your 4s, it's possible you have a 5 and a 1, 5 and 2, 5 and 3, and so on. So you should start to see as you get to that last column there, you have your 6, right? Your last number on that number cube, and then continue to finish that out. 6 and 1, 6 and 2, and so on. So again, this is all of the possible outcomes that you could have if you roll 2 number cubes. This is what you would see. So count how many are possible here. You have 6 rows going across, 6 columns going down. You should be able to see out of all of these outcomes, there are 36. So when you roll 2 number cubes, a pair of dice, you should get 36 outcomes possible. So we're going to look at the probability of rolling doubles. right, so I'm going to use a highlighter here. And the probability of rolling doubles, I'm highlighting. It's just in this diagonal here. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There's 1, 2, 3, 4, 5, 6 possible doubles. So when we fill this out here, 6 possible doubles out of the 36 outcomes that are there. So we talked about with probability, you should reduce it if you can. So that's 1/6. And then we talked about percentage and we talked about decimal as well. So if you do 1 divided by 6 in your calculator, you're going to see 0.16, and the 6 is going to repeat over and over. And so let's just round that, okay? So if I round to the nearest whole number, we're talking about 17% of the time, 17%, you would see doubles appear out of the 36 outcomes that you have. So this, what we just completed and looked at, this is called theoretical probability. So over to the side here, I'm going to write that out. And this definition is in the next few pages, and we'll talk about it obviously, but theoretical probability is what should happen, So you should see doubles 17% of the time when you roll 2 number cubes, okay? Now, the next question is having you just kind of predict what could happen if you roll these number cubes 50 times. It says, how many times would you expect doubles to be rolled if you roll those number cubes 50 times? So basically, take what you just got here. So this 1/6 or 17%, and predict. Meaning, if you roll these 50 times, actually, you know what? I'm going to also write the decimal here because I'm going to use the decimal. So 1700ths. Take your decimal and let's multiply it by 50 times. So 0.17, 1700ths times 50. And we're going to predict, if we multiply this out, you do get a decimal, 8.5. So you could say 8 to 9 times you could see doubles appear. 8 or 9 times. So again, you're taking what you found in step 1, where 17% of the time you're going to see doubles. But if you roll the number cube 50 times, you do an experiment, then you could see doubles 8 to 9 times. Okay, so step number 2. So it says actually roll the number cubes, the 2 number cubes, and record the number of doubles in the table. And you want to do it 50 times. So normally what would happen here is you would do this and you would record how many doubles. I already completed it, okay? And so I'm going to tell you, and you're just going to copy here because you don't want to sit here and watch me roll these 50 times. Okay. I'm going to record on there that I got doubles 6 times when I did it. Okay, so just trust me that I did it. 6 times when I rolled the number cubes, 50 times, I got doubles. So now what we're going to start talking about here in step 2 and 3 is what's called this experimental probability. So here, I'm going to write this off to the side as well. And this definition is in the book coming up shortly as well, experimental probability. So in experimental probability, this is what happens in the experiment itself. Okay, so what we actually see when we do the experiment. And so we're going to take a look at right now in step 3, the number of times that we rolled doubles when we did the experiment, and the number of rolls. Well, in my table, I show that I got 6 doubles out of the 50 times I rolled it. So this denominator, this bottom number, is your experiment number. How many times you're conducting the experiment. I conducted it 50 times. I rolled these number cubes 50 times, and when I did, doubles showed up 6 of the times. Okay, so this is what happened in my experiment. Now, it says to compare the ratios in step 1 and in step 3. And what do you notice? So, in theory, I'm going to put a T here. For theoretical, what should happen, get a little bit closer here, is you should see doubles 6 times out of the 36 possible outcomes, or 17%. Okay? In theory, theoretically, what you should see is with your number cubes, there's 36 outcomes, you would see doubles 6 times. That's what should happen. Now, when you conduct an experiment, okay, so when we compare these two, I'm just going to write E. And in my experiment, I got doubles 6 times just by coincidence out of the 50 rolls in the experiment. Now, divide that out and see what you get as a percentage. 6 divided by 50. So when you divide that out, you would see 12%. So in theory, what should happen, 17% of the time, you should see doubles. When you do the experiment itself, when I rolled it 50 times, I saw doubles 12% of the time. So what should start to happen, so if you look at this next question, suppose the number cubes are rolled 100 times. So now what it's asking me to do is go from 50 tosses in the experiment to 100 tosses in the experiment. And what would you expect to happen? Would you expect the results to be the same? Why or why not? Well, if you double the amount of times you do the experiment from 50 to 100, what should start to happen is your experimental probability should get very, very, very close to theoretically what should happen. So the way we're going to word this is as you, let me just turn this a little bit. As you increase the number, of trials in the experiment, the closer you get to theoretical probability. So as you increase the number of trials in the experiment, the closer you get to theoretical probability. So I'm going to tell you, because I don't have it anywhere else on this page to write, but I'm going to tell you, if I tossed it 100 times, okay, so I doubled my experiment. I tossed it 100 times. This time, I definitely got more doubles than I did when I tossed it 50 times. And so I actually got about 16%. So again, the more trials you do, the more times you conduct the experiment, you're going to get closer and closer and closer to theoretical probability. Sometimes you might get it exactly the same. That can happen. So this is an introduction, like I said, to theoretical and experimental. Just looking at number cubes to start with. So now what we're going to do is we're going to head into the next video. So this video is going to stop. You're going to go to page 722, and we're going to practice just a little bit more today, and then we will wrap it up on Friday. So you'll stop this, and I'll meet you back in the third video.